Okay, today we are going to work on another method for solving a quadratic. It's called using the quadratic formula. And all I have up here at the top is just a big box for you to write the quadratic formula in. Now, similar to factoring, you have to set your quadratic equal to 0. And honestly, in this case, we usually try, if we're factoring, to keep the squared term positive, but that does not matter in the case of the quadratic formula. You just have to set it equal to 0. Once you have it set equal to 0, you're going to identify your a, b, and c values. A is going to be coefficient of your quadratic term, b is going to be coefficient of your linear term, and c is going to be just your constant or your plain number, and then you can just plug them into this formula. Sometimes the answers are nice, sometimes they're really complicated. It depends on the question. They can be real or they can be imaginary, and this is what it looks like. So x being your answer, or your zeros, or your solutions, however you want to say that, is going to be equal to, this is a big fraction, negative b, or opposite of b, plus or minus, to give us our plus or minus for our two answers. We've got b squared minus 4 times a times c, that's all under a square root, and then the whole thing is over 2 times the a value. So we're just going to apply this to solve the equations on the notes today. So first thing I have to do is set my equation equal to 0. So for this question, the least amount of work for me to do that would just be to subtract 4 from both sides there. So I'm going to have 3x squared minus x minus 4 equals 0. Alright, now I'm just going to identify my a, b, and c values. So a is 3. B, I just have minus x, so b would be negative 1, and c is going to be the plain number, which is negative 4. We're just going to plug them into that formula that you guys see above on your paper. So my answer, opposite of b, is actually going to turn into be positive 1, and then plus or minus square root b squared, negative 1 squared, 4 times the a value is 3, times the c value is negative 4, everybody over 2 times the a value, which is 3. Alright, now, however you want to do this, I usually do it in a couple of steps. But if you want to grab your calculator to help you or not, you don't have to. I'm going to grab mine here real quick and lay it up here for you guys to see. So what I normally do, I just keep the outside for a second. Now I'm not going to type the square root, I'm just going to type what's under the square root. So I have negative 1, I want to make sure that's in parentheses, and the squared on the outside. That first term under the square root should always become positive because you're always going to be squaring something. And then minus 4 times my a value is 3 times my c value is negative 4. Make sure if you're using the calculator to do this that you use that negative key and not the subtraction sign for that negative 4. So I'm not using the square root here, that's just what's under the square root, which ends up being 49. The bottom of that fraction, it's just 2 times 3, so 2 times 3 is going to be 6. Now, this particular question is really nice for us because what I ended up with under my square root was 49. So that's a perfect square. So this is really 1 plus or minus 7 over 6. Now, you can simplify that. So from there, we want to actually go ahead and do that. So I'm going to do 1 plus 7 divided by 6. So that would be 8 over 6. Now, if we can reduce the fraction, which I can here, I want to do that. So that's really both of those divisible by 2. So that answer is really 4 over 3. My other answer is going to be 1 minus 7 over 6. So that's going to be negative 6 over 6, which means my other answer is negative 1. All right, let's try the one next to it here. Again, you have to set the question equal to 0 before you start. Easiest way to do that here, I'm just going to add the 9. Actually, the way this question was set up looks really similar to what we were doing for completing the square. We could solve this completing the square also. We're just trying to work on the quadratic formula today as a new method. So I'm going to set that equal to 0. All right, my a, b, and c values I'm going to identify. So a is 1, just an x squared, so just 1x squared. B is going to be 6, and C is going to be 9. All right, so I'm going to start out opposite of B. We're going to do negative 6 plus or minus square root 6 squared, and then 4 times our A value, which is 1, times our C value, which is 9, all over 2A, so just be 2 times 1 for this question. Okay, now like I was telling you guys on the last one, I usually figure out what's under the square root without involving the square root. So I'm going to do 6 squared minus 4 times, I don't need that multiplication symbol, 4 times 1 times 9. I'm just using the parenthesis keys right above the 8 and 9. Now, this one's also interesting. So I end up under the square root. 6 squared is 36, and 4 times 1 is 4, times 9 is also 36, so that's how that ends up being 0. So I really have negative 6 plus or minus 0 over 2. Okay, well, if I add 0 or subtract 0 from negative 6, either way, it's going to give me negative 6. So this is kind of a more rare question, but this actually only has one answer, and so just be negative 6 over 2, which is negative 3. Now, just to give you guys a reference here, if we were to have graphed the related quadratic up here, what that means, the vertex would be your 0. So it would have been like negative 3, 0. It would have gone up 1 over 1. So the related quadratic would have looked like that. If you only have one solution, that means the vertex is what's going to touch the x-axis in that situation if we were talking about the graph. So just negative 3 is the answer for this question. All right, and then I got one more at the bottom of the page here. Now, I do want to tell you something, just like with factoring, if you notice all the terms have something in common, like I immediately notice all these terms are even, get rid of that so you're working with smaller numbers. You can, if you don't notice that, that's okay. You can always use the quadratic formula. We would just be plugging in a lot bigger numbers. But I'm going to notice right there that all those are divisible by 2. So let's just get rid of that so we're working with a little bit smaller numbers. So this would be x squared. 36 divided by 2 is 18. So minus 18x. And then 112 divided by 2 is going to give us 106. So I haven't set that equal to 0 yet. I probably should have done that first, but let me do that now. So I'm going to set this equal to 0 before I identify my A, B, and C values. Now, if you wanted to go ahead and use 2, negative 36, and we're going to add this to the other side, so it'd be positive 212. If you wanted to use those numbers, we would actually get the same answer. The simplifying would just look a little bit different. All right, so for here, my A, B, and C values. A's 1, B's negative 18, and C ends up being 106. Now, like I said, if you want to use 2, negative 36, and positive 212, we'll get the same answer. The algebra is just going to look a little different. All right, let's see. Opposite of B here is going to be, because this was negative 18, positive 18, plus or minus square root, negative 18 squared, 4 times 1 times 106. And then the whole thing over 2a, so 2 times 1. So again, I'm just going to grab my calculator and figure out what we would have under the square root there. So I'm going to do negative 18 squared minus 4 times 1. I really don't need the 1. That's just going to keep that for 106. Okay, now this ends up being negative. So 18, I don't need the plus sign. I don't know why I just wrote that again. Square root, I didn't include that. I just figured out what was under the square root. But this is negative 100. This is over 2. Now, this is also nice for us because negative 100 is a perfect square in imaginary land, if you remember. But as soon as I've got a negative under that square root, we're going to end up with an I in our answer here. So I'm just going to write 18 plus or minus. Now, this negative 100 under the square root simplifies to 10i, everything over 2. Now, here I can't combine any like terms in terms of adding or subtracting because 18 is real and 10i is imaginary, so those would have to stay separate. But if all three of these are divisible by the same thing, which they are here, 18, 10, and 2, they're all divisible by 2, you can reduce this. So that's going to be how we want to write our answer. So 18 divided by 2 is 9. I'm just going to keep the plus or minus symbol in the middle. 10i divided by 2 is going to turn that into 5i. So this is our set of two answers. They're both imaginary here. 9 plus 5i and 9 minus 5i. Okay, now these couple problems I got on the back here are going to be a little bit more complicated than the ones we did on the front. So this says in the directions, give exact and approximate solutions. We haven't run into this yet because everything we've had under the square root has either been a perfect square or a perfect square in imaginary land. So we're not going to have that on these two questions on the back. We're going to have something that's not a perfect square under our square root. And so I'm going to show you how to deal with these two different requests in this question for what we call an exact and what we call an approximate. For the approximate, you would need your calculator. Okay, I'm going to start out and set this guy equal to 0 to start. So I'm going to add the x squared and just combine that with the 2x squared I already had. So we're going to then have 3x squared plus 4x minus 2 equals 0. And I don't see anything in common between those terms. They're not all divisible by something, so we're just going to work from there. All right, our a value is then 3, b is going to be 4, c is going to be -2. So that's what we're working with. And we're going to use our quadratic formula. So opposite of b would be -4 plus or minus square root. B squared is 4 squared minus 4 is part of the formula here. A lot of 4's in this question. A is 3 and C is -2 all over 2A. So for this question, 2 times 3. So I've got -4 plus or minus, and then I'm just going to take and type what's under the square root. Just do this in a couple steps here. So we've got for this question, I've got 4 squared minus 4 times 3 times -2. And again, just be careful, use the subtraction sign between the 4 squared and the 4, but you use the negative key for that -2. And under our square root here, we're going to end up with 40. So I haven't taken the square root. And 2a here is going to be 6. Now, we're going to use some bunch of skills in this question. So if you can break down the 40, so if you are into the factor tree, or I like to find the biggest perfect square. So biggest perfect square that's going to go into 40 is 4. So I would just do 4 and 10 real quick. And then 2 and 2, there's my pair. Now you can break down 10, that's 5 and 2, but that doesn't give you another pair, so I would just put that back together. So square root of 40 is just going to simplify to be 2 roots of 10. So that's what I'm going to do over here, is replace the square root of 40 with 2 roots of 10. Okay, now for my exact answer, this is not quite simplified, but this is super important. Do not touch, once you've simplified the radical, do not touch whatever you have underneath there. Now, if all three of these numbers, so I've got -4, I've got 2, and I've got 6, if all three of those numbers are divisible by the same thing, which they are for this question, they're all divisible by 2, you can reduce that, but do not reduce or do anything with what you had left under the radical, so just leave that alone. So I'm going to turn that -4 is going to become -2 plus or minus. Now this 2, if I reduce that, would become 1. I'm just going to kind of lightly write that because typically you would not see a 1 in front of the radical here. So I just have that square root of 10, and then the bottom would be 3. Now these two guys are what we call our exact answers because I have not rounded anything. That is an exact answer. If you want an approximate, and you can't do approximate solutions if you have imaginary numbers, they have to be real. So if there was an I involved in this, which there's not, but if there was an I involved in this, we would just have exact solutions. We would not have approximate solutions. Now, approximate, and I don't think it says this in the directions, but I'm going to have you guys round to the nearest 100th. can't even space this out right, sorry, nearest hundredth, which is going to be 2 decimal places. So you're literally just going to type this into the calculator. So I'm going to do -2 plus the square root of 10, and then I'm going to divide that by 3. Now, this is really important. When you work with the calculator here, it follows the order of operations. So I want to simplify the top of that fraction first. So I'm just going to do -2 plus the square root of 10, and I'm going to hit equals. All right, and it's going to give me a nasty decimal, but just leave that right on the screen. That is the top of the fraction. You have to do that sum and then divide that whole sum by 3. So then I'm going to divide by 3. All right, so approximation. So I'm going to say this is approximately equal to 2 decimal places. I would call that 0.39. Now, I want to show you the difference. This is why you can't type it all in at once. If you type -2 plus the square root of 10, don't write this, and divide that by 3, in your order of operations, the calculator will do that division first and give you the totally wrong answer. So you got to figure out what the top is, hit equals, and then divide it by the bottom. So to get my other answer, we're going to do -2 minus the square root of 10 over 3. So -2 minus square root of 10, and then just hit equals right there. And then we're going to divide that by 3 to get our other answer, approximately about, whoops, I forgot the negative, -1.72. And if you guys were to look at this, if we set this equal to y and graph this on Desmos, these would be the 2 places you would see the graph cross the x-axis, so they would not be at nice numbers. All right, we're going to try one more problem here down at the bottom of the page. So set equal to 0, I'm going to add 7 here. So we're going to be working with 2x squared plus 6x plus 7 equals 0. Again, I don't have a greatest common factor or anything here, so we're not going to divide anything out. We're just going to go ahead and identify A, B, and C. So A is 2, B is 6, C is 7. And we're just plugging it into the formula. So opposite of B, -6, plus or minus B squared, which would be 6, that looks like a B, 6 squared, minus 4 times A is 2 times C is 7. I don't know why I put an extra parenthesis there, sorry. And then 2A, 2 times 2. So -6 plus or minus square root, let's just do square root on the calculator, or what's under the square root. So I'm going to do 6 squared minus 4 times our A value is 2, our C value is 7. Okay, now this is going to give me -20, so we're going to have an I in our answer. I know that immediately. And the denominator there would be 4. All right, so -20 under a square root. Again, if you want to use a factor tree, use a factor tree. I'm going to break this down as the biggest perfect square. Biggest perfect square that goes into 20 is going to be 4. And then what I do is I just attach the negative to that perfect square. So then when I remove this, I'll just take the I right with it. So square root of -4 would come out as 2i, and we'd have a 5 under the square root. If you want to use a factor tree, feel free, but just remember, make sure you have an I out in front of your radical, because if you're working with a negative under the square root, we got to take care of that with an I. Okay, now I'm just going to replace this for the square root of -20 here. So we got -6 plus or minus 2i radical 5, everybody over 4. Okay, now, again, I want you to look at this before you write your answer. Do not touch the radical. Whoops, let me not cover up the I with my finger. Okay, if all 3 of these, and this doesn't always happen, but it's going to happen here, if all 3 of these are divisible by the same number, you can reduce this. And each one of those, 6, 4, and 2, they're all divisible by 2. Just do not touch the radical. That radical has to stay the same. So to reduce this, that -6 is going to become a -3. The 2i just becomes a plain I. Can't get rid of the I because we have a negative under the square root, so I know I'm going to have an I in my answer. The bottom of this would become 2. And then you just keep on the top with the I, you just keep exactly what's under the square root. That does not get reduced, just whatever's in front. And I kind of mentioned this to you guys these are exact solutions here. I kind of mentioned to you on the last question. If you have an I, you can't do an approximate solution because you can't add those together on the calculator. So we're just going to leave that as our answer. Anytime you have an I, you can reduce, but we can't write it as a decimal because that's not an appropriate way to write that. And that's your quadratic formula.